So the question that I aim to answer with my project is whether or not a shipment with a fixed transportation route has more accessorial charges or cost than shipments without fixed route. So the first thing that we looked at, or that I looked at, were these two columns here, transportation, which tells you if the shipment has a fixed route or not, and the accessorial cost, which tells you how much accessorial cost was charged to the route. So the first thing I did with that was I moved them over to these two fields, SO fixed and SO not fixed. So in the SO fixed CSV file, we have all of the routes that have a fixed transportation route and their associated costs, and we have all of the routes that are not fixed and their associated costs. And so with this data, this was all done in R, but since there was a few mistakes and some trial and error, I moved the clean code to this Word document that we can walk through. So the first thing I did was I saved these CSV files and I loaded them into fixed. So we'll start with the fixed data. So I moved into fixed 2, and I named the one column accessorial cost. I ended up eliminating this column A here because there were some issues with it. So we just had the one column, and I created a bar plot from fixed 2, which looks like this. So we can see that we have a wide distribution with one potential outlier in the middle. And then so I looked at the mean and standard deviation, and I coded the standard deviation into the word deviation, as you can see from this grouping of fields here. And so then I created 4 AB lines, one with just the mean, one with mean plus and minus standard deviation, one with 2 standard deviations, one with 3 standard deviations, which you can see here. So we can see that this line, the bottom line, is the mean line. You can't see the less than 1 standard deviation because it's below 0. So this is the first standard deviation, second standard deviation, and third standard deviation. So you can see almost every single data point is within 2 standard deviations of the mean, and only 1 is outside 3 standard deviations of the mean. So this tells us that there aren't really many outliers, just this one key outlier in the data. So when I created a summary of the data in the fixed 2 CSV file, we can see that the median was $16 of accessorial cost. Median was $16 of accessorial cost. The median was $81. The max was $1,300 accessorial. So then I created a box plot based off this data, which looks like this. So you can see very low mean down here, but you can see a lot of high outliers. So what I did with this was I used outline equals false, which will remove the outlier points, which we can see in this box plot. So you can see the outlier points are gone. It's a much cleaner looking box plot, and it gives us a better representation of what the data means. So as you can see, this median line right here is the same as our 16, and we have our quartiles and our high point. So then I repeated the same thing with the not fixed appointments. So I moved the CSV file to not fixed, named it transportation and accessorial cost. We found our mean and standard deviation, and so we created our bar plot, which looked like this. Which, as you can see, much more data. These had 15,000 data points as opposed to a couple hundred, and there's much larger spread of values. And so then we created our AV lines, which you can see in this code here. And so this, we can see you have all the way here towards 0, you have the mean, and then 1 and 2 and 3 standard deviations. So far more points which were far above the 3 standard deviations above the mean, a lot of outliers potentially, and a lot of values close to 0, because even with these outlier points, the mean is still way down here near 0. So suggests that perhaps even with these outliers, there's a lot of not costed, or trips that don't cost anything, even without the fixed appointment, which we can look at when I made this box plot. So with the same method, just a regular box plot at first and then one without the outliers. we can look and see this was the first box plot where you can see there's a ton of so many values down here near 0 that it's indistinguishable, and lots of outliers, which is this solid gray tube that goes up. It's outliers layered over each other. And then when the outliers are removed, we get a much cleaner box plot, which you can see the mean is close to, it's below 2, very close to 0, and everything is within 12 when compared to first the fixed data where the mean is 16 and values are between 250. So based on this data, I concluded that the not fixed routes have significantly lower cost than the fixed routes. We can see that both without the outliers and without the outliers, especially with the box plots with the outliers removed. The mean is just so much lower, and the quartiles and all the summary data. You can see here your median is 1, your mean is 14.79 as opposed to 81, and although the max is much higher, there's so many data points of 0 or 1 cost that it drives the total cost down. So we know that the routes without fixed appointments are less expensive than the routes with fixed appointments. So my next part of my project was looking at a regression model, multiple regression model, because I wanted to see how significant these variables were in relation to other variables and in predicting accessorial costs. So what we looked at was 4 different variables in the model. So we looked at the order quantity, the total volume, including pallet, the total weight, including pallet, and the transportation. So for transportation, I changed all of the old codes into binary codes. So you can see here that there was a number of different codes in this column I that indicated whether or not it was fixed appointment or not. So 0 represents a not fixed appointment, and there's 1s that represent fixed appointments. So by changing it to a binary variable, we're able to use it in a multiple regression model, with the y variable being associated cost, and then order quantity x1, total volume x2, total weight x3, and transportation x4. So I coded this all into R. I took this CSV file and called it reg data, regression data. I gave names to all the columns, and then I coded y as the accessorial cost, x1 is quantity, x2 is volume, x3 is weight, x4 is transportation. So I ran a few different models. In model 1, we fit all 4 variables into the model. And as you can see, x2, x3, and x4 had very low p-values, 4.38 to the -6, to -6 to -16, and fairly high t-scores. But x1 did not have a very high p-value of 0.35. So since based on the data in the box plot, we could have expected x4 to have strong significance, because we knew that the routes with no fixed appointments had low cost, and the routes with fixed appointments had higher costs. So obviously they would result in accessorial costs rising or falling. So this had an f-stat of 267.3, p-value -16, although very low r-scored. So this suggested that although these 3 variables may be significant in the model, there's a lot of other variables missing, and there's a lot of variation still in the model. In our model 2, I removed x4, thinking that just to look at what the model would look like without it, since we knew that x4 was probably going to be significant even before we did this regression. So I just fit the model with x1 plus x2 plus x3 and called the summary data. And we can see here that x2 and x3 got again, very low p-values. And x1's p-value goes down, but it's still above 0.05, still not significant. Our f-stat went up, our r-squared went down, so we can see that removing x4 caused a bit less predictive value for the model. So x4 was definitely a valuable predictor. But again, the same results, x2 and x3 are significant variables, but not correlating, or not providing a lot of the predictive value. So in the final model, I removed x1, which had proven to be not significant, and I ran the model just with x2, x3, and x4. The r-squared adjusted was about the same as model 1. The p-value was the same as model 1. The f-stat was higher. But all 3 of these variables continued to be significant. So again, the final conclusion being that routes with fixed appointments are right now appear to be more expensive than routes without fixed appointments in terms of accessorial costs. And when it comes to predicting accessorial costs, we can see that total volume, total weight, and the type of transportation are all significant factors in that model, but none of them provide significant predictive value, meaning that we will need to look at a lot more variables in this model to truly come up with a predictive model. And we know that order quantity probably is not significant in determining accessorial costs.